Hello everyone, my name is Devashish Roy. I'm the Senior Network Analyst at the Indian Cybersecurity Solutions. And today I welcome you all to this special webinar. And today's topic is a very interesting one. That is a multicast routing. We'll be discussing about the Cisco multicast routing. There are two protocols, protocol independent module, not the protocol independent multicast, but the protocol independent, and the IGMP, that is the Internet Group Management Protocol. So let's start and discussing about the multicast. What do you mean by multicast? How it is different from the unicast or broadcast? So we're discussing about the multicast routing, the PIM and IGMP, and it will be an in-depth exploration of multicast routing protocols. Now, first of all, what is a multicast? Multicast means a communication between a source and many receivers. Say there is a group of receivers, like say for example, I am taking a class. That is a multicast. I am communicating with a group of students. I am communicating with a group of computers. That is a multicast. We have to understand the multicast routing now. Multicast routing is crucial networking technique that enables the simultaneous transmission of data packets to multiple recipients and reducing the bandwidth. Like if you send one to one, say unicast communication, definitely you have to spend a lot of bandwidth because for each data stream you require separate bandwidth. But for multicast, you have to send it all together. That is the advantage. Multicast routing means single packet, multiple recipients that I've already told you. Multicast routing enables the transmission of packets to multiple recipients simultaneously and optimizing network resource usage by avoiding the need for multiple copies of data one by one. It sends all together. Bandwidth efficiency is increased by using multicast routing. The bandwidth consumption is significantly reduced as data is only sent once over the network. It is key for real-time applications, like it is essential for the IPTV or some say the gaming applications. You can also generate multicast by say VLC media player like that. So you have to install that and you have to generate the multicast traffic. Otherwise, you can ping the multicast address like the class D 224 to 239 is reserved for the multicast. Key protocols are PIM protocol independent multicast. PIM is essential for multicast routing, allowing for efficient data distribution across diverse network. Now, there is a question that what is the difference between PIM and IGMP? There is a confusion. See, PIM is between the routers. Okay, between the ISP routers or between the service provider routers, that is a PIM. And IGMP is for the end devices between your PC and your router, your gateway. That is the IGMP you configure. Like we configure, say, IGMP, we enable the multicast routing, and then we configure PIM dense mode or PIM sparse mode. You can configure. Now, dense mode is best suited for networks with a high concentration of multicast receivers. Now we'll discuss the dense mode in a bit. We'll configure also in a JNS3, but dense mode is the by default method. Dense mode means like there is a multicast source which is sending the multicast traffic. Say you are pinging a multicast address, and there is a join. There is a client that will be able to join the multicast group. Now in dense mode, the video stream will be distributed to everybody. Let's say one client doesn't want to join, but in that case also that is not possible because that video stream will reach that client also. It will be directed like a broadcast. Dense mode, it is inefficient method, you can say. It creates a lot of traffic. In case of sparse mode, it is not like that. Sparse mode is designed for networks with a limited number of multicast receivers, like everybody doesn't want to participate, few want to participate. So if I want to participate, I will only selectively join the multicast group. That is a sparse mode. It utilizes a shared tree and the rendezvous point, and for efficient routing, minimizing the amount of multicast traffic on the network. So by default, it is dense mode. If you want, there should be an RP, rendezvous point. So rendezvous point means it is a server. Everybody will contact that RP. It is a shared distribution tree. So there are two methods. One is the dense mode where everybody is participating in the group forcefully. Other is through the RP, and it is a sparse mode. Then you have to understand the IGMP. IGMP is essential for managing multicast traffic and it allows hosts and routers to communicate about multicast group membership within an IP network, and it enables efficient data transmission by ensuring that only devices interested in receiving multicast streams join. Because see, one device want to join the multicast group, it sends a report request. We call it a report request. It sends it to the, let's say it's neighbor router. And now that neighbor router sends the join message. This is how the IGMP works. Now we have different versions: IGMP version 1, version 2, and version 3. Let's discuss. Version 1 is a very basic one. It is the original version of the Internet Group Management Protocol. It focuses primarily on the basic multicast group, but the problem is what? In the version 1, you do not have the leave option. Means if one host has joined the multicast group, then it has to remain joined. If it wants to leave, it cannot send the leave request. If it sends, it will not be forwarded to the source. That is a big problem. In the version 2, yes, it has enhanced efficiency with leave message. IGME version 2 introduces leave message. Now it allows hosts to explicitly leave multicast group, which enhances the overall efficiency of multicast traffic management. Because you have to leave, you may leave the group because that is the option for you. Definitely that should be there, but in IGME version 1, it is not. Now, what is the difference between version 2 and version 3? It is almost the same, but in version 3, it is source specific multicast support. What do you mean? Means, say for example, there are multiple multicast source. Now, I can select from which host I want to receive the multicast. That is the difference in the version 3. So you can configure the PIM on Cisco routers. We'll see in a moment in GMS3. Enable PIM on interface. So you have to enable the multicast routing first. Remember, otherwise you cannot enable PIM, you cannot enable IGMP. Then you have to enable the PIM and you have to activate PIM on the desired network interfaces. Whatever interfaces you want to participate, you have to enable the PIM, and you want to enable either PIM dense mode or sparse mode. Step 2, configure PIM mode that I've already told you. Step 3 is set up neighbor relationship. You can do it with the routing protocol. So these things I've already discussed, and you have to configure IGMP snooping. You can do so that the switch analyzes which interface is part of the multicast group. You can do it, is an optional feature. And configure IGMP version, that you can also do. You have to troubleshoot the check the PIM neighborship status. If there is some problem happening in the multicast routing, issues happening, verify IGMP group membership and monitor multicast traffic flow. So this is like the theory part regarding the brief discussion of the multicast. And now I can actually take you to the GNS3 console. You are running, you can see a server and a few nodes are there. So let me switch on the nodes first. They are switching on. And already the IP address is preferred for the internet routing, but BGP is preferred for the internet routing. Backbone you can say, so you can configure OSPF for static routing, anything, because it should be the network should be advertised like this is 1.0, 2.0, And a loopback is there in R2, that is, I think it is 5. Okay, this is the configuration of the multicast routing that I was showing. So let me start the nodes first. Let the routers be started. 239.1.1.1